Welcome everybody. Welcome to our most recent webinar in our webinar series from the NGSS ESS Working Group. And today we are joined by a number of people. Here we go. This reminder that this webinar is being recorded, so I think you just hit that button and said okay. So the title for today is Traveling Through Time with the International Ocean Discovery Program, Scientific Ocean Drilling Reveals the Earth's Past. And we are joined today by Ed Robeck from AGI, myself, Missy Holzer from Nesta. Aida's not with us today, but she is here in spirit. So welcome to Aida from NAGT. And joining us today in the background and supporting us is Ashley from NAGT. So, and our presenters today include Ed Robeck from AGI and his team, Lauren Brace and Lindsay Mosa, and they're joined by Carlos Alvarez-Zacarin from IODP. So as the webinar proceeds, please drop your questions in the chat and we'll answer them. If the team sees them along the way and can answer them, they'll do that. If not, we'll gather them and we'll use them in the Q&A when we get towards the end of the program today. So again, thanks for joining us and enjoy the webinar. Okay, rid of that, and we'll do a switch to Lindsay.
Okay, we good?
We're good. Thank you, Lindsay. Hi, everyone, and thanks for being here this afternoon. The Education Outreach team from AGI, just introduced Lindsay, Lauren, Sequoia, and me, are looking forward to sharing some resources from the International Ocean Discovery Program that we've been engaging with over the past 18 months or so. We're also pleased to be joined by Carlos, who's a geoscientist with IODP, and who will introduce himself and tell you a few more details in just a few minutes. Our focus as we go into this webinar begins with recognizing that there are some important ideas that in the geosciences that we tend to share with students. Ideas such as the fact that there have been, or the idea that there have been impacts of objects from space, including the Chicxulub asteroid impact, and that those have had important effects on our systems. The broad concept of plate tectonics that helps us to explain a wide range of geologic phenomena, including locations of earthquakes and volcanoes. The important realization that processes can have catastrophic effects on people, and that those same processes, such as earthquakes and tsunamis, have occurred and have had effects throughout Earth's history. The recognition that Earth's oceans have environments that, despite having what we would consider extreme conditions, support diverse, thriving communities of living things. These and other ideas are integrated into earth science curricula. But in NGSS aligned instruction, exploring these ideas need to go beyond being able to explain them clearly. We have to ask, where is the evidence for such ideas? And moreover, where is the evidence that we can have students engage with directly? To really address such questions, we have to have data that help us travel back through time to those periods in early Earth history to reconstruct conditions, processes, and events underlying these ideas. And it's with this in mind that we'll begin sharing information about the International Ocean Discovery Program and the resources that it provides to educators, students, and scientists, and others. We'll provide some general background about IODP and the scientific ocean drilling that is at its foundation. We'll also work through a couple of activities that make use of IODP data, and we'll share where and how you can obtain more activities and the data from IODP.
So to give a little background, scientific ocean drilling has been around for over 50 years with an international team that takes samples from the ocean floor. They access some of the Earth's most challenging environments in order to get samples of sediment in the form of cores, as well as rocks, fluids, and living organisms that show us about Earth's history. And this has really changed how we understand how our planet works, being able to look so far into our Earth's history and the well-preserved record that exists on the seafloor and the sub-sea floor. So some connections, going back to the list that Ed just shared with some discoveries that IODP is responsible for, we have these direct connections to NGSS standards. And so one of them being that asteroid impacts can be looked at multiple scales. So in middle school earth science standards, we see that we want students to be able to explain geoscience processes over time and spatial scales. And with asteroid impacts, we can see they have a small relative impact size-wise, but then the dust that comes from that can be seen all around the globe. And so we have that spatial scale, and obviously the time being punctuated by a catastrophic event has a direct correlation there. The fundamentals of plate tectonics are seen as something that we're actually going to be engaging with today by looking at fossils as a unique way to look at how plates have moved over time by fossils on the bottom of the ocean, knowing the date and the ranges in which they lived and being able to see where they have moved along with those plates over time. And then some more recent research with long-term borehole monitoring systems that have been put into place by the program. They're able to look at how earthquake and tsunami hazards are the extremes of our life's planet and affect the life on the planet. And with this NGSS standard, we look at what are some natural hazards as well as ways to mitigate their effects, and monitoring is a big part of that. And so through these direct connections, we want to help you explore data and see why bringing cores into your classroom is a good idea, and also how it's going to be able to show students how we really understand things that have happened across our planet. And with that, I will bring on Carlos, who will talk more about the program.
Oh, and Carlos, you're muted right now.
I just unmuted myself. So good afternoon again. My name is Carlos, and I am a staff scientist and expedition project manager for IODP. And I am based in College Station, Texas, a very small town, not really that very small, but between Houston, Dallas, and Austin. I have been here as a staff scientist for almost 20 years. Scientific ocean drilling is possible thank you to a small fleet of very specialized vessels that you can see on the screen. We use three vessels, two that are dedicated for what we do. The US is the one who operates the JOIDES Resolution on your left, and Japan does the Chikyu that is on your right. And then we have a consortium of different countries that operates what is called the mission-specific platforms. And these are particular platforms that are used to get to locations where our ship or the Japanese ship cannot go, like in the Arctic Ocean or in very shallow water where we cannot go because we have very big ships. These ships are at the cutting edge of the technological innovation, and they continue to push the boundaries of what we can do. In the small table in the bottom shows you sort of a comparison of the number of cruises that we have done. And in the last 10 years of operations, the JOIDES has completed 46 cruises. The GQ and the MSPs have completed each of them 4 different cruises. Can you go to the next slide? This video was from an expedition that I did a few years ago before COVID, and is the JOIDES Resolution sailing through the Magellan Strait in Chile. And the JOIDES was built in 1978 and was converted for scientific ocean drilling in 1985. And it has been working with the Texas A&M since that year. Between 2006 and 2008, the JR was completely renovated with new scientific drilling equipment, and also with many structural improvements that were done to the vessel. And it got a very significant upgrade in what it could do. It is now owned by a company called Overseas Drilling Limited that is a subsidiary of the SIM Offshore in Norway, and it's operated by Texas A&M in College Station and through funding from the U.S. National Science Foundation. As you can imagine, the JR is not only a floating lab, but it's also like a college or a university, because we have people from all over the world, teachers, scientists, really very well-known scientists, and also students who are actually learning from them. Next slide, please. Over the past 10 years, the JR has sampled deep below the seafloor in all the world oceans except for the Arctic, as you can see in this little graphic on the left. And the circles, they represent how much core we have collected from each of the sites that we have drilled. And the biggest circle is about 2,000 meters of core that we have taken from the seafloor, going back in age to the late Miocene or even into the early Miocene, which is about 15 to 20 million years of age. Go to the next slide. Each expedition aboard the JOIDES sails about 120 people. And each cruise includes a multidisciplinary team of scientists from 22 member countries of IODP. And they have extensive support from the marine technicians who sail with us, computer experts, from graphic experts, from the drilling crew, the ship crew, from educators who are sailing with us in every expedition, and also from many other people, including chefs and stewards who do our laundry, who clean our rooms, and who do everything that they can so that we can focus on working for 65 days in every cruise. And together, we work as an international team. We work 24 hours, 7 days a week to advance the knowledge of our planet through scientific ocean drilling. We are like Earth detectives, if you can imagine, and time travelers. Next slide. This is a clip of how we collect cores from the seafloor, and I'll let you hear.
Solution is to drill into the ocean floor and bring up sediment cores for scientists to study. These sediment cores can give us a lot of information about the Earth. Many pieces of pipe are put together under the derrick on the rig floor into what is called a drill string. The crew attaches a drill bit to the end of the drill string and lowers the entire thing through an opening in the bottom of the ship called the moon pool. Once the drill string reaches the ocean floor, coring begins. A long cylinder of plastic called a core barrel is lowered through the drill string, and the sediment cores are collected inside it as the drill string rotates. The core barrel is then pulled up to the ship through the drill pipe and onto the rig floor, where the technicians and crew collect it and begin to prepare it to be examined by the scientists.
Okay, I give it back to you, Lindsay.
Yes, thank you. And so what we want to show you today is how you can bring these cores and the data from IODP into your classrooms. And so one of those things is by looking at the cores themselves. So understanding that the cores are split in half lengthwise, and samples are taken both on the ship and also from scientists who maybe have never been on the ship, but want to use the data from these cores in order to have evidence for what they're looking at. And so that can cover a range of topics, as we've already discussed and as we will discuss, but this is how they are looked at on the ship. And so then what's available to us is not only images of these cores, but also activities as well. So we're going to engage in 2 activities today. The first one is called Cores for Kids. And so this is a simplified lesson, which is going to be able to introduce students to what cores are, because there are some lessons on plate tectonics, as we mentioned, on climate change. There are a lot of different topics that are covered by the lessons that have been written by people who have been on the JOIDES Resolution and interacted with this data. However, that initial introduction to the cores is really important to get students to understand why it is that these cores have been taken and also what they can look at with that. So you will be shortly receiving a link to a Google slide set. And within that, you're going to see an image of the core like you see here with microfossil samples that have been found along its length. And then you'll be given a key for those samples, which will allow you to match up the ages with those samples similar to what they would do on board the JOIDES Resolution, just in a simpler format. And again, this is just for initial introduction to the cores, and then we have lessons that will take students beyond that to be able to look in more detail. So I'll just give you a minute to look at that first Google slide and match up the fossils with the ages that are given. And so then to look at that second slide there, another thing that we can look at with the cores is sediment types. And so the way that I made the file, hopefully you can zoom in on the core in order to be able to view the different layers in more detail. But then while you're doing so, make a hypothesis. What types of sediment and rocks do you think are found in those cores? And why do you think that is? Where might these sediment types have come from? And so there's a text box there that you can make copies of and put notes along the cores on the different observations that you're making. So kind of put yourself in the frame of mind of a kid who's never been introduced to these cores before. And what do you think they might observe, and what do you observe about these cores? And when you're ready, maybe throw some hypotheses into the chat. So what kind of sediment do you think you're looking at in these cores? Okay, so some red streaks, which might indicate iron. It's for our more advanced students. Okay, some clay. Silt, mud, maybe volcanic ash. Okay. And so we would want our students to say, why do they think this is? So again, they could indicate color. Okay, so maybe different rock types, absolutely. And maybe that a lot of the sediment that you're mentioning are things that we would find at the bottom of rivers and lakes or on a beach. And that might be something that students are familiar with. Grain size, okay, so you're looking at the small grain size, absolutely. And then Sequoia put into the chat already the link to the full lesson that we have here, which is also going to be highlighted in AGI's Earth Science Week calendar that we made for this year. And in that, you'll be able to see the poster. So the poster that you can show students will go through detail on the microfossils that are found within the cores. It'll go through the details of the sand and silt and other sediments that are found within the cores and possibly where they are from. So getting students to really think about the origin of those sediments, how they get to the sea floor, and what information they could possibly give us about Earth's history. And again, this could be a very quick introduction to get students to just look at the cores, see what they contain, and really think about what they might be able to tell us. So some analysis questions that you could do with students would be, how do the ages of fossils change with increasing depth? So for example, looking at the trend. So, and feel free to answer any of these questions in the chat if you'd like. So if we're looking at the depth, so knowing that the top of the core is where it says 0 centimeters is shallower, and then going down the core is deeper down into the seafloor sediment. Okay, why do you think the fossils are not evenly spaced throughout the core? So even if you don't have an answer to this question, it's just something to get students to think about, you know, what is it that's going on that there might be more or less fossils within the core, or why are there the layers different thicknesses? Why might the layers be different colors? So that was mentioned by a couple people that there were tans and grays and reds in there. So, you know, what's the process that's going on that's getting the cores to be different colors? And also just a general question, what else might be in the cores that a scientist or you would want to study? And I do want to give you a minute to answer this question in particular, but what are some questions that you might ask about the cores, or you might ask your students to get them to think about, you know, what is in there that you might want to study? Okay, there's definitely cracks in some places along the core, so maybe what caused those, whether it was the process of bringing up the core or geoscience process itself. What isn't there? Interesting. Okay, so what do you think they were expecting to be there that maybe is missing? All right, and then, yeah, these are just kind of generating questions in order to get students to think more about those cores, because this lesson can be modified for really any age group. So you could have them then look into the different types of sediments and rocks in order to get more information about them, depending on the age of your students. You could use a model or another hands-on investigation like a stream table to actually show the process of deposition to get them to understand how the layers could be formed in the first place. And then you can also compare different sediment core images. So these, for example, are all taken from the same Gulf of the Corinth and Greece. However, they're all showing different layers, different patterns, different sediment types, and getting students to think about why and the different geoscience processes that could be studied in a particular core is really a good way to engage them in that question asking and thinking process that can then get them to understand more complex data. And then we also have where they came from. Absolutely. Are they found anywhere else? Perfect. Yes. So some things that scientists are going to look at within this is the rock and mineral composition, kind of like we discussed, but also looking at the chemistry of them and various ways that they're affected by magnetism, seismic waves, radiation, heat conduction. And then one of the primary ones we're going to focus on today is microfossils. So what kinds of microfossils are found within the cores, and what can they really tell us about the history of our Earth? And so I'm going to hand it back over to Carlos to talk more about those microfossils.
Thank you, Lindsay. Well, as you already heard a little bit about the microfossils, you know, they are the most important and beautiful components that you can find in the ocean sediment cores. And these are tiny fossils that generally you can only look at them with the help of a microscope. And they are used to study Earth history. They are very important because in scientific studies, and also in the industry, like in oil industry, in the mining industry, because they are very helpful to help us understand how to reconstruct past environmental changes in climate and in the environment. And they can help us tell the ages of the rocks and the sediments that we are collecting. So we can learn about how old a rock is or how old the sediment core is by looking at the microfossil assemblage that you find in them. And you can correlate different strata that you find in the different cores using the fossils as well. Go to the next slide. Microfossils, they can come from plants and from animals. Some are organic, some are calcareous, some are siliceous, phosphatic, and they can also be coming from land. So they are not only from animals or from plants that were living in the surface of the ocean or that were living in the bottom of the sea, but they can also be coming from land, either by wind or by rivers that are bringing the sediments into the ocean. And they can range in size from a few microns, which is very, very tiny, to a few centimeters. Go to the next slide. Some examples of the organic microfossils can include dinoflagellates and pollen and spores that you can see on your left-hand side. Examples of calcareous microfossils can include coccolithophores, foraminifera, and ostracods that you can see in the rest of the slide. And you can have a sense of how small these creatures are by carefully looking at the shell of the benthic foraminifera that you see on your right. And this specimen is about 1 millimeter in length, if you can imagine. And when you look in detail at the shell of this organism, you can see that it's made of very tiny coccoliths. And each of these coccoliths are cemented together to produce the shell of the benthic foram. And each individual coccoliths that you can see in there is about only 2 microns in size. Can you go to the next slide? And other fossils can be made of silica, as I mentioned earlier, and they include radiolarians, which you have in the center of the slide, and diatoms that you have on the left. You can also find very tiny fish teeth in the sediments. They can be of a few microns because they are very tiny fish, but then you can also find some other bigger teeth like shark tooth and so on. The following slide gives you a table that provides a size comparison between the different fossils, the most typical fossils that we find in the sediment cores, and you can see sort of what kind of range do they have in size.
Yeah, and this is another diagram you could show your students to get them to ask questions. So you can talk about scale, you can talk about range, and ask them about the various organisms that we find. And so you can see the scale at the top mostly encompasses most of the groups there. I only made it up to 2 millimeters to represent the majority of them, but you can even see forams because they can go much larger. I made that arrow there so that you can see that they have a much larger range in sizes. So lots of questions that you could ask your students about those ranges there. All right. And so now we are going to go into another activity, which is going to allow you to look at a virtual expedition. So what you see on the screen here is going to show you a little bit about how to use Google Earth with a KML file. So if you're familiar with that, if you open it up, goes into Google Earth, and it shows you a layer with information in it. And this information for this one in particular is looking at an expedition and 7 holes that were drilled along the Mid-Atlantic Ridge, with specifically microfossil evidence being collected in order to look at the age of seafloor sediment. So you have just been given a link to a Google Drive that will take you to a few files, which I'm showing you here. The bottom 2 are the actual lessons. So there's the teacher version and the student version. A little bit long for us to read right now. We're kind of on a time crunch here. But so I made that middle one, the virtual expedition walkthrough. I made that video is about 4 minutes, which will take you through the KML file in order to be able to see what you'll be able to look at on Google Earth. Or if you already have Google Earth downloaded, because it does need to be the downloaded version to use the seafloor spreading KML file, you'll be able to kind of like walk through it and click through it and see how the data is laid out. And then there is an extra file, a little bonus for you here. This dynamic earth actually shows the age of the sea floor, and it will overlap that along with the data from the seafloor spreading one in order to be able to look at a few different points of data at the same time. So the whole goal with this is for students to be able to look where cores are taken from the ocean, especially in this one in relation to the Mid-Atlantic Ridge, and then looking at the age of those fossils. So if you go through the student version, you'll be able to see a data table with microfossil samples, and you compare them to the ones found at the different drilling sites and see their ages, which you'll see then will match up with that dynamic earth layer. And so this is what some of the microfossils look like, but we want to give you some time to look through some of these materials. I highly recommend watching the video for now, as we have about 6 minutes for this, and just kind of looking through and seeing what data do you see at those different points.
Lindsay?
Yes.
So I got a question in the chat about what is being shared right now. Could you go through that again?
Yeah, so I shared the link again. Sequoia had put it in there a few minutes ago, but it says the virtual expedition to the Mid-Atlantic Ridge. And it's a Google Drive, similar to what I showed on the screen, with files that can be accessed. In particular, the video file will walk you through the use of the KML file on Google Earth. And
That's
then
the MP4.
yes. And then I know there was a question about the Google Earth downloaded version not being supported. So I do have a free version of Google Earth Pro, and it works really well with this file. Thank you, Victoria. I'm glad you like it. Sorry to have to rush people through that, but just want to give you a few minutes to be able to explore it in order to see what you could have your students interact with. And again, doing a video like that is definitely something that you could do as a modification if you're not able to access Google Earth, or your students are having difficulty with it. But we wanted to see, how can microfossils be used as evidence of seafloor spreading? So in the full lesson, there are analysis questions that will allow students to be able to look at the microfossils, compare them to a table of microfossils of known age, and then look at a geologic timescale in order to determine how old those fossils are, and then compare that to the distance they are from the Mid-Atlantic Ridge to see how they have moved over time. And then also the number of different points there offer the ability to graph the data in order to be able to visually see that the distance correlates with the time. And then also there's an equation in the student version of the lesson as well, in order for them to be able to calculate seafloor spreading rate. And so while most people are thinking, looking at the basalt or the actual crust on the ocean floor, the seafloor sediment is going to give a different line of evidence that's going to be able to help students understand geologic processes like seafloor spreading. And what might be some other ways you modify this for your students? I understand that you probably didn't have very much time to look at it. If anyone has an idea, you can put that in the chat. But like I said, one good modification could be having a video tutorial going through the KML file for them to see that, as well as once they determine the ages of the fossils, being able to add in the second file that shows the age of the seafloor, to show that if they get those microfossils correct and they identify them correctly, then they're able to actually verify that data using the known age of the seafloor. And we have a number of different lessons. So within the larger folder that you got from Google Drive, you'll be able to see each one of these lessons. And this is just highlighting the NGSS that is addressed by each one of these. So you'll see there's 3 middle school earth science, 1 middle school life science, and then 3 high school earth science as well. So there is definitely a way to step these up and make them a little bit more difficult for older students. And then we do have a range of other lessons that we will show you in just a little bit, but these are ones that we have helped the program to revise in order to align them with these standards. And with that, I'm going to hand it back to Carlos to talk more about how to access IODP data.
Thank you, Lindsay. IODP data collection begins aboard the ship with the recovery of the first core. You can see some of the scientists and techs that are carrying one of the cores on what we call the catwalk. And it continues on board as the scientists are taking samples from the core. They describe the sediments, the different rocks, and they take samples from these cores to do their shipboard analysis, which can range through a whole broad from geochemistry to paleomagnetism to biostratigraphy, and you can just name it. At the end of an expedition, the cores are sent to one of the 3 IODP core repositories, and the data is transferred to IODP databases, where the data will become available to the public and the scientific community after a 1-year moratorium. During the moratorium, only expedition scientists have access to this data. The cores recovered from the expeditions, as I mentioned, they are sent to repositories. We have 3 repositories around the world. The cores recovered from the Pacific and the Antarctic Oceans are sent to the Gulf Coast repository, which is where I am. The cores recovered from the Atlantic and the Arctic Ocean are sent to Bremen in Germany. And the cores recovered from the Indian Ocean are sent to Japan, to the Kochi Core Center in Kochi, Japan. And together, these 3 core repositories, they contain or store more than 450 kilometers of core that we have collected since the first scientific drilling program, for about 50 years. We have been collecting cores. Next slide, please. The IODP data collected by the JR is stored at our library information management system, which is what we call the LIMS database, and can be accessed through our website using a LIMS report portal that you are going to see in a few seconds. Before you go there, you can first search online for topics that you would cover in your classroom, such as the one that are listed on your left of the screen, to discover specific expeditions that targeted any of these topics. And once you have decided once you have learned which expeditions cover these topics, then you can go to our website and investigate through our report system, so through our database. If you go to the next slide, the reports are organized by data types for the convenience. So if you want to look for a particular data type or topic, you have a list of topics on the left. And once you select the report that you would like to learn about, then you fill in the different fields that are on the right. Once you fill that information in, then you click on View Data. The data will appear on the bottom of your screen. And once it appears in the bottom of the screen, then you can press the Download Data on the right there in the middle, and then you will be able to download the data to your computer. Okay, because we don't know how long the database will be in service into the future at this point in time, we are transferring and copying all the data to Zenodo for long-term storage and access. And curation and scientific data that has been collected from the mission-specific platform expeditions is being stored at the Pangea database in Europe, which is the one on your right-hand side. Once, if you go to the next slide, please. Once, on the other hand, if you don't want to look specifically for the data from the expedition, you want to look for references, for the citations and information directly of the results of each expedition. You can do so by going directly to our webpage and then you're selecting the cruise you're interested in. There we have all the reports that were written during the cruise. And we also have a scientific ocean drilling bibliographic database where it contains records from all the different cruises that we have made since 1969 to the present. And you can use just a keyword to look for a specific topic, or if you want to look for fossils for each particular type of fossil, you can just put it there. And that will allow you to have a list of all the publications that have been done related to the topic that you are interested in. And I think that's the last slide about data. And now lesson revisions.
So we at AGI have been helping this program to revise their lessons. So there are 100 lessons that have been developed over the past 15 years on the JOIDES Resolution website, and we will get you the link to those resources. And they, again, cover a wide variety of topics that we've mentioned before, like climate change, plate tectonics, asteroid impacts, and things of the like. These existing materials are currently being revised for consistency and for contents. So the data is really good, but we're just making sure that the pedagogy is there. So we're helping the program in order to revise them, in order to make sure everything includes data that's generated by scientists that are using IODP data. We also want high resolution images from these expeditions, so of the cores themselves, and also of slides of the cores. And also incorporating hands-on activities. So I mentioned before, yes, and accessibility, absolutely. And so by doing this, we're going to allow students to be able to understand the concepts by working hands-on, but then also then connecting that with this real-world data that is provided by IODP. And so, like I said, using the pedagogy that we know that you are all using. So by aligning materials with standards that we know that are being used nationwide, as well as ocean standards. So the 2050 science framework, as well as the ocean literacy principles, define what students should be able to understand about Earth's oceans and the sediments and living organisms within that. And we want to make sure that these lessons are in line with those as well. And with that, we will have time for questions. And I know I saw a few pop up in the chat. So I think I'd turn it over to Missy.
That was amazing. Thank you so much, Lindsay and Carlos and Ed. So we have an array of questions in a little bit amount of time. Ones that we've compartmentalized into talking about the JOIDES, talking about the lessons, as well as talking about the data itself. So let's go ahead and, since we're talking about the lessons, we have a few questions regarding that. So first, how does the IODP interact with students and teachers? Are there opportunities for students to visit the JR?
Carlos, you want to take this one?
Yeah, well, the JR is it moves around the world, we know, and it just goes from port to port every 65 days. So to be able to visit, you can visit when the port, when the ship is in port at any particular city in any particular country. Right now is in Amsterdam, and the last time that I sailed with the School of Rock was also from Iceland to Amsterdam, and I know that there were, in every one of the port calls that we have done, there are groups of students who are coming from the local schools, and they are visiting. But it is something that it has to be arranged, at the port, and with the people who are going to be attending the port call, and the ship hasn't been in the United States since it was last in San Diego. I think it was in 2018 or 17. And so at the moment it's in Amsterdam, as I said, and I think that if you fly to Amsterdam, it will be very possible to go visit. Yes.
Sure. Thank you, Carlos.
You're welcome.
To piggyback on that question, while we have you here, there's a question from the chat. Can we visit virtually?
Yes, you can. You can visit during an expedition. You can actually visit virtually. We have an educator or two educators who sail in every expedition, and they are in charge of setting up, constantly, daily Zoom meetings with different schools and universities, museums. It is an opportunity that is very easy to get. You just have to contact, I think that the people from the USSP can hook you up directly with them with the ship. At this moment, there is an educator, how can I say, like a training that is taking place on the ship. I think, you know what, I was wrong. The ship is in Italy. It's not in Amsterdam. I think it's in Italy. Yes. You can do it. Yes, you can do the virtual visits just to make it fast.
That's
Yeah.
great. Thank you so much. So continuing with the student work, are there any materials or places you can direct us to if we want to observe microfossils that have come from the cores?
So many of the lessons that are on the resources that we provided will show kind of a curated collection of microfossils. So it's kind of good guidance that they're identified and there's information for them where they came from. The database that Carlos shared earlier, you can also search microfossils on that as well. There's just a lot of data on there that makes it a little bit more difficult. So I would start with the lesson plans and then kind of work your way up to looking at the database. And Carlos, is there a microfossil specific area on those databases?
Yes, there is, but it's within the desk reports, which is basically the description that the scientists do for the biostratigraphy. You can either download the data in Excel tables, or you can download pictures that were taken either with the SCM or with a microscope on board of the different fossils. So we typically carry two scientists for every type of fossil group that we will encounter during an expedition, and they deposit all that information in there. So you can download the tables in Excel, or you can download the images. Yeah.
Great, thank you. Now, kind of going along those lines, are there tutorials? I was watching how you were going into the database and pointing us to everything. Are there tutorials to help an educator who hasn't used a database like that to put together a query to pull up what they would need for a lesson?
Not that I know of the tutorials per se. I mean, the database initially is a little bit, I wouldn't say hard to work. You just have to get used to the way it works. But once you know, you can easily go through it. As it was mentioned, as we mentioned, is better to look for a particular topic that you're interested in, and then identify which expeditions focus on those different topics, and then search for the expeditions, and then go into the database to download what you think it is. And if any questions, you can always contact us. There is an email in the database. There is an email that you can just send us an email, and we will answer you.
Oh, that's terrific. Thank you so much. The chat is abuzz, so those of you that are on, please take a look at all the resources that are being shared in the chat. At this point, I think we're going to come to a close for the webinar. As I said, we have a number of questions related to the cores themselves, as well as related to ship operations, but we're coming up against the top of the hour. So at this point, we're going to transition to the close of the webinar. And so I'm going to switch with Lindsay with sharing screen. Okay, great, thank you. Whoops. No, you see my messy desktop. There we go. And there we go. All right, great. So a big thank you to our presenters today for such a wonderful, compact webinar. I'm looking forward to using the materials myself. Well, this was the last webinar for the NGSS ESS working group for this season. We're starting to put our heads together to plan for the fall. So watch your emails for announcements for upcoming webinars for the next season. But remember that all of our webinars are archived. You can find them on the NAGT website where you register, but you can also find them on the AGI YouTube channel as a playlist. So you can pick and choose for all the webinars that we've hosted throughout the whole series. And this one will be posted in no time at all. Okay, so there is a survey that you can fill out, and if you fill out the survey, we will provide you with a certificate of participation. So please do so. I don't know that link will take you exactly to this particular webinar, but it will take you to a survey, and then we can just look at the data and gather the data for this particular one. So thank you for filling that out. All the information you provide for us is super helpful. So something else, just to remind you for the K-12 educators here, that we created this site for you to go to search through for opportunities, summer opportunities and opportunities throughout the years. So if the JOIDES Resolution was running a School of Rock, you would see it posted here. So we encourage you to jump onto this website and see what's available. This webinar series is hosted by three teams, NAGT. And so for AIDA, I'll just mention that NAGT is a wonderful organization that spans mostly higher ed, but they are also in K-12. They have a webinar series that they host on a regular basis, so please visit. And please visit their site for all of their resources. Remember that they are home to the wonderful projects that are hosted on CERC. For myself, wearing the NESTA hat, National Earth Science Teachers Association, our focus is on K-12 education and outreach. And we have a monthly newsletter we send out. We have a curated journal that we send out to all of our members. So feel free to join us, and we'd love to have you. Ed?
Hi, and there are many different resources that the American Geosciences Institute provides for educators in all different settings, including many different countries. So please take a look at the website. And one that you may already have heard of is our Science Week. And we've just redesigned that website. So there are a lot of resources there that are also wonderful to look at, and including resources that have come from other organizations that we've compiled onto something called Education Geosource, so that you can find those easily and search that database by topic to get to those resources as well. So thanks for being here.
Great, thank you, Ed. And at this point, I'm going to thank our presenters again, and also Ashley Carlson from NAGT for all her background work for us, helping us. Thank you very much for joining us, to the audience. Have a good day.
Thank you. Bye.